All right, should we go? Great. I believe we are live.
We should be.
Awesome. Yeah, let's make sure we have the comments going too. Let's see if we can do a little test of that. Actually, don't see the comments here. Are other folks able to see the chat?
Yep.
Here we go. Awesome.
Yeah.
All right, I think we are live. All right, welcome everyone. Let me get back to, here we go. Okay, all right, welcome everyone. And if you're on LinkedIn or YouTube, or I don't know if we have a direct stream link, say hello in the chat as well. Already seeing a couple messages here. So yeah, welcome everyone. Leo, founder over at Graphistry, helped start all the GPU graph investigation work and helping with the current Louis AI work. And then we've got here with us for our first show, Sindre, who I'll let him introduce himself in a second. And then our guest for today, for the first session, Henning Rauch, from the Microsoft Kusto team, and you might also know him as Professor Smoke. So welcome.
Oh my God.
Yeah, and maybe let me do a little bit of ceremony before we kind of introduce folks here. This is like our first one, so first of all, thank you for joining us. It's going to be a pretty wild season. And I think the first the episode here is a good example of what we're trying to do, where basically we've been lucky enough to work with all these amazing people over the years, and it's actually honestly been very hard to keep up with everything that's happening. So this is also kind of a selfish thing where we were trying to figure out how the heck do we actually get into these more interesting conversations that are going on. And then in turn, instead of having to repeat one by one with everyone else we talk with, well, why don't we just do some sort of shared live thing and kind of instead of having all of these as closed conversations, use this as an opportunity to kind of share what's going on from all these different aspects. We do a lot of data intensive investigations, so you're going to hear a lot about GPUs, graph, AI agents, LLMs, all that kind of stuff. Yeah, we're going to be trying to do 1 or 2 of these a month. To get notified about these, go to louis.ai, sign up, and then there's a little marketing email that we'll be trying to do advanced notifications. Also, if you're a YouTube or LinkedIn user, there's some sort of subscribe system. So I think we have to hit that subscribe button? Is that what the people?
Yeah. Thumbs up and subscribe.
Exactly. Yeah.
Like and subscribe.
Like and subscribe. Okay. I don't know if you do that on LinkedIn, but whatever the corporate version of that, do that one too. And then just some other things. We'll get into all the Kusto Microsoft Henning stuff in a second. We'll have we're lining up a bunch of fun folks for this season. One of the next folks, I don't know if it's the next one, but as an example is one of our friends, Roberto Rodriguez. He runs the AI agents, the AI SOC over at NVIDIA, and you might have known him from all sorts of online things like the InfoSec Jupyter-thon and helping do Microsoft's AI Red Team efforts. And anything else here, I think, in our little list here for things to notify. Yeah, a couple more. If you want to catch up with us in person, I think Sindre and I will be over at Sindre will be over at Black Hat EU at the Arsenal, sharing some open source work. And then at the end of the year, we'll actually both be at the Chaos Communication Congress. So if you're in Hamburg, come say hello. I don't know, Henning, are you gonna Any big upcoming events?
Actually, I'm going to be in Hamburg in the same period of time, but I'm going to go to Lions King, I believe.
Maybe it'll be like a
ECC or Lions King, let's see. Quite a spectrum.
Awesome. Yeah, that's actually, maybe we should do that. We should have done it in person. Oh no. Okay.
Yeah.
And then I think we had one more, which was actually, yeah. So for our side, we're actually getting ready for a big Louis announcement. I can't say what it is just yet, but hopefully when the recording is out, we'll be able to, by then I'll be able to say. But meanwhile, I just highly encourage you to, oh, I like that. Yeah, we have shiny stickers now. Yeah, go to louis.ai, sign up for the EAP, and then what you'll actually also get is early notification of the thing we're about to announce, and then you can actually get early access that way. But yeah, I can't say what it is. Cool. All right. So with that, maybe Sindre, maybe just for the folks who might not have met you yet, you maybe introduce yourself.
Yeah, I'll do the sort of short version. So for any native English speakers out there, you might notice I have a bit of an accent. That's because I'm coming out of Norway. So I'm a former police officer and investigator in Norway. I worked as a security analyst at an MSSP, and I've been working with Graphistry for a better part of a year now. And I'm a lover of graphs. And I've been following Leo on Twitter for a better part of 6 years before starting working at Graphistry. So big into graphs. Luckily now I'm working here and seeing all the cool stuff I watched from the outside prior. So it's fun.
Yeah, and I don't know, Professor Smoke. I don't know if so. Okay, like maybe let's start digging into here. Maybe as a little softball. I don't know if what's your, like, I'm guessing, I don't know where you are on the AI thing, but definitely I feel like graph has been a part of your life for a few years now. So maybe what's your most kind of memorable or imprinting memory of graph or AI? Like, kind of, why do you do this?
Oh, wow. So first of all, yeah, Sindre is a police officer. I'm actually a judge. So it's quite funny. So I'm a lay judge in Germany. I didn't tell you that. I'm also a firefighter. If I'm not a firefighter or Professor Smoke in Call of the Cyber Duty, I actually have a side gig as a principal PM at Microsoft. So, that's really just a side gig. Oh, wow. So graph experience, I've been in graph since quite a while. Actually, after my studies at the Technische Universität Ilmenau in Germany, I studied computer science. I joined a startup where we built graph databases from scratch. So I still claim that we created the first graph database which was running on Azure. Okay, so that's my claim. And then, over time, it was always like an on and off relation with graphs, more on than off. And at some point, I was very lucky and still very grateful that I was able to join Microsoft. And eventually, I joined the Kusto team. And then eventually, I was able to be like super, super stubborn and introduce graph in Kusto as well. So
that was you. Okay, interesting.
Yeah, no, I was very stubborn. And, back in the days when I was working for other kind of companies, I always combined stuff like Cassandra and Elasticsearch, like great databases, and created my own in-memory graph database. But, having such a complete offering such as Kusto, which allows you to do multiple things, that was like super interesting for me. And adding graphs was just, I would say, natural evolution of the engine itself. So if you ask me about my aha moments and when it comes to AI and graph, I really have to admit, Leo, it's probably one of your videos, the boss of the sock stuff. I shared it so many times and I had to laugh so hard about it because, it was so well made, I have to say. It was just an amazing video, just an amazing show. And it shows the strength of this technology, in my opinion.
Yeah.
Maybe it made me look bad, though.
Yeah, I want to say. So
maybe, also very funny.
Maybe somebody on the team could dig up a link and drop that in, and then the one of the fun things here, a little Easter egg is, well, okay, let me step back. So for folks who have no idea what we're talking about, so the Splunk team puts on their Boss of the SOC CTF, like Analyst Investigation CTF every year. And we decided to, instead of benchmarking Louis on our own benchmarks and just reporting that, like, well, let's see if instead of having a team of folks do stuff for like an entire day, let's see how Louis can do on the CTF. And we just threw that in our benchmark set. And then we actually found it was actually able to solve like maybe in the first run about 3/4 of the CTF pretty fast. But here, and so fun video, we put together a share of it, but here's the Easter egg. So you might recognize like we basically pitted our intern versus some senior analyst for the competition, and that's the video. And you might be looking at one of who that senior analyst is. So take a look at the video and see if you can figure out which one of us in this video is the senior analyst.
Yeah, if I ever need to apply for a new job, I'm not putting that as a reference.
getting beat by the intern. Yeah.
Yeah.
Oh, that was super cool. And then the other things when I do like stuff in Kusto, my wow moments are every time when I do something like a root cause analysis. So a customer has a specific problem, and then we have this system which is called Kus. So it's the Kusto cluster of all Kusto clusters. It gets all of the logs and telemetry of all clusters on the world, which is quite a bit. I'm going to talk about that later. But if you're in some environment like VS Code and you checked out the Kusto code and you have access to entire logs, you have an MCP server which is able to like query your log system, and you are eventually also connected to the customer system if they consent. Then you can find stuff like that you never thought of, and it's super cool, especially me as a PM where I don't have like the entire knowledge about each and every implementation detail. It's very easy for me to say, okay, over there's the logs. I know when it roughly happened. This is the cluster. Here are the parts in the code that might be related to that. Now go figure out. And I get some really cool hints, which like, allow me to take the next step. So that's definitely an aha moment.
Yeah, that I think so. Folks who don't know, I used to build programming languages, and it's like a tool builder. It's always that moment where you're building it for the community, but in a sense you're also building it to scratch an itch, right? And then that moment where you actually could use your own tool on your own job, like that's always just like one of those like bootstrapping, like, whoa, okay, this is it, that's awesome. And so I guess like maybe also to make it a little like clear for what you're saying there, I want like the Office Space clip, like where the two guys are like leaning in, is like, what is it that you do here? So like you say you're like a PM, like what does that mean? Like how do you work with Kusto in the community?
Oh, that's an interesting question. I actually that my role is PM, so I'm a product manager. So this means I'm responsible for a few features in Kusto. So one of these features is, for example, I introduced our geospatial clustering algorithms, which is super important if you're getting like a lot of telemetry data from all kinds of systems with some geospatial data. You want to be able to aggregate that, and that's why I introduced those clustering algorithms. And then also for quite some time, also responsible for security in Kusto, customer-facing security, everything around network security. So I'm sometimes I'm designing those kinds of features. Sometimes I'm bringing my own intuition. Most of the time, I bring customers who require certain stuff, and then I'm structuring their requirements. So classic PM work. But nothing is that classic in Kusto. Kusto is a very vibrant team, which might also be a little bit different than other teams at Microsoft. So on one day I do marketing stuff, another day I do like coding with customers, and the next day I'm getting invited to this beautiful webcast. So it's like very diverse stuff, and there's no day that it's the same.
So actually, you might have, because you've like been around so much at Microsoft, especially with the Graph push, then you might actually be able to give insight into this one. So over the years, like I've been noticing more and more Graph at Microsoft. Like the first thing I noticed was like the Graph API, which like that's the use of the word graph. But like deeper was like John Lambert, obviously, like attackers thinking graphs, defenders thinking lists, right? Like that quote. So he definitely been like a drumbeat going on there. but I felt like the last few years, like Kusto Graph, Azure Sentinel Graph I think is in public preview. Maybe it's GA, and then I don't know, Fabric. I don't know if that they're doing anything, but like I feel like one by one, like Cosmos DB has Graph. Like, yeah, like is it the water? Like, is it like the new CISO? Like Igor? Like I know he does Graph stuff. Like, what's going on?
What's going on? So that's a really good question. So first of all, when I joined Microsoft, I was in 2016. I was very much disappointed that there was no like really cool graph technology that we had. Like other hyperscalers, I think did a better job. I still remember though in 2010, when I was still working at this startup, there was an initiative or a product or research product at Microsoft called Trinity. So a distributed graph processing engine, which sounded like super impressive, and I thought, okay, we are done, guys. We can stop. We can stop doing whatever we do, and just go home and do something else. But eventually, what I learned is that all of these products that Microsoft built, the graph stuff, they never really reached customers. They never really reached end customers, and that's, I believe, what changed. And for us, what changed especially was around the time of 2020, 2021, where Microsoft, and still was under heavy attack of like nation-state threat actors. And we really had to help. And we really had to support. And as all of this data from security guys or from securities in Kusto, it was kind of like a natural evolution to bring some of the graph goodness to where the data is sitting. So that's why we decided, and actually also were funded, to build some graph capabilities directly in Kusto. So that's why it advanced since then. Of course, like there are like a ton of other engines which also support graphs. You mentioned a few, Cosmos with Gremlin, SQL as well, and also Fabric Graph. And if I look at our announcements, for example, at Ignite is one of our largest conferences. It's definitely clear that graphs are centered to Microsoft. They're really strategic to Microsoft, not only for security, but also for the entire AI and agentic work that we're doing, because it's easier to use graphs in order to reason over distributed data, the data that sits in different kind of like platforms even, right? So it's about cross-domain analytics, and here graph definitely helps, and also helps to reason for AI agents. So
that makes sense to me, because like we actually put like an article out like a few years ago at the beginning of the vector database craze, where it kind of felt actually analogous, where it's sort of this question back then when it was first starting is like, do you get a dedicated vector database, or do you get do you just get a vector index in your regular database? And if all your security data is in Kusto to begin with, well, why, like, it's just more natural to be able to, like, within that flow, let's like add a vector index, let's add a graph index, like whatever those common ones. So that definitely tracks. And I'm sorry, go for it.
And that's definitely what we try to achieve. So we started with relational. We added time series over the years to Kusto. We added geospatial and a bunch of other things. And from positioning point of view, we never wanted to compete with those large graph databases that are out there in the market. There are a few of them. All of them do like brilliant work, and we never really wanted to compete with them. But at the end of the day, I see that a lot of customers are using this technology because of the reason that you don't want to maintain like multiple systems. And it's still some kind of language gap. So if you have, for example, Cypher on the one side, or OpenCypher or GQL or whatever, and then you have all of your data in Kusto, it's kind of a language gap. And we try to make that easier. That's why we deeply integrated it directly into our language, so that analysts have an easier job at the end of the day.
So then I know there's like we've been building out for like Graphistry and Louis like integrations for I feel like every time we get one integration done, you guys like make another feature or new like thing, right? It's a little funny getting it so you can talk to all this stuff. But I guess I'm to your point then, like, okay, so Kusto makes certain stuff with Graph easy, but then also there's like these other like Microsoft products and vendors, whatever, that do other kinds of like graph database or graph analytics stuff. So kind of like, when do you yeah, like maybe you take us a bit through like when do you start with this stuff in Kusto, and then when might you reach for like, hey, you know what? Let me start here, but then if I hit this point, this is when I might want to think about something else, or maybe I'm not even thinking about it the right way.
No, that's a good one. So I mean, there are multiple dimensions to that. You already mentioned Sentinel graph. So that's a security focused graph, right? It's stuff that's important for security researchers, for SOC teams, and all of that. So that's one specific domain. If you're searching for something that's not domain specific, then you need to go probably one level down and to the engine level, and you can pick something like Kusto. So if you want to use if you want to be in a different domain like IoT, industrial IoT, whatever, then it might make sense to go like one level deeper, or you pick the next level, which is on par with the Microsoft Sentinel graph, and go into something that's domain specific in here. I think the point where it makes sense to use Kusto over something that's highly domain specific and only graph focused is if you have to combine different kinds of algebras. So relational algebra, time series stuff. For example, very often I see security researchers searching for anomalies first. And for anomalies in time series, there's some built-in operators in Kusto. So you detect those kinds of anomalies, and then you try to calculate the blast radius from there. And the blast radius might be the graph part. So first you have time series, and then you have a blast radius. Or if you want to do something like GraphRag and calculate, like, for example, the geospatial proximity and compare it with the semantic proximity by using something like a Gaussian similarity function. All of that is available in a single engine. So if you really need to do like in a single engine using multiple different algebras in the same query language, then I think Kusto is actually the right thing to use. If you have something that's only graph specific, there might be other services like Fabric Graph, for example, who is dedicated on GQL.
Yeah.
And they have a scale-out graph algorithm, which is based scale-out graph engine, which is based on technology from LinkedIn, which is also super cool. Then that might be the better option, right? But if you need to combine different things like time series, vector, geo, relation stuff, then you're probably better off in Kusto.
So you might like start in Kusto because your data is already there. Maybe you get used to the graph stuff. I'll do, visualize in Graphistry, talk with Louis, whatever. But in reality, it's just a few queries, simple things in there. Maybe figure out your use case, and then you figure out, well, maybe my use case is multimodal. I need to stay in there. Or you know what, this is the small version, but to really scale up, I might need to move my data over. But now I have the business case because I actually showed the small version.
And here's one thing that's very important to mention is here's Microsoft. I think we succeed when we make things simple. And one thing that you mentioned, like moving data over, that's something that's not really happening any longer because we have this concept called Fabric. And in Fabric, all of the data is supposed to live on one lake. So in an open format, and all of the engines which are on top of that, maybe Data Warehouse, Spark, KQL, all of them are working on data sitting in one lake. So the data. So what I really like about it, that customers don't have to choose which one to use in the first place, and then they're not forced to continue with this engine if it doesn't work out for them. So yeah,
I gotta ask you a question, Henning. Like, how hard is it to start with this? Like think about it as like, small SOC. You might be Sentinel focused, and then you go like, we've never looked at graphs. Where would you start? Would you start with Sentinel graph, or would you go to Kusto straight out of the box? Like, what's the learning curve?
So again, this is a really good question. I always recommend people to start with the domain-specific stuff first, and if it works well for them, go for it. If the business model works well, go for it. Go for the domain-specific stuff because it's all about time to market, time to value. And if you're in something that's more domain specific, and then that should work better for you because it's like faster time to market. However, what I found out, like talking to a lot of customers, and I mean, no shit, Sherlock, it's very, very hard to get started with graphs.
Yeah.
It's incredibly hard for some people who only know lists and operate in lists. They don't think in graphs. And I still remember that I forgot the conference. But I created an MCP server just for making recommendations on what kind of graph data do I have. So it looked at different tables and said, okay, so this could be combined into a graph. This might make sense to put into some kind of a model. And for people and analysts who are just focused on like their daily work, like work in lists and stuff from like just go through each and everything, I think it's very hard. I believe that agents could also help here just to generate those kinds of graphs and graph models. But there's also something interesting which we're doing at Microsoft right now. It's called Fabric IQ, which is connecting the Power BI semantic models and create ontologies with that. And that allows you to connect time series data, graph data, and your entire business data in your Microsoft ecosystem. And it makes it way easier. So I usually recommend people go from the top to the bottom. And if those things that are like domain specific don't work, go to the SaaS level. If the SaaS level doesn't work, go to the PaaS level. But start at the domain specific one.
Yeah, and have that clear use case, have that problem you're solving, like go where the data is already set up. Yeah, that tracks a lot, especially what you're talking about, starting with like, what is that graph and like what, like in ours, like I don't know, Sindre, if you agree with this, is I think a lot of our times like we kind of pair like on one end we're like, okay, top down, what is the business case, like what's actually worth driving this, and let's just see if we could do whatever minimal, easy, smallest thing just to make sure we're going down the right way. And then the next part is like, before we even go into AI or moving data or big, any of that stuff, it's just like, let's just do some easy queries. Let's do some basic shapings of that existing data into some simple graphs. Let's just see if there's actually a there. Let's just visualize it, look at it. Does this solve?
It's basically like the first wow effect, because we see that a lot. Like doing that simple demo of just doing IP to IP. And turning that into a graph, like here, this is how your network is talking to itself. Like, and people like, I've never seen it like this. Wow, but what is happening over there? Like,
like for me,
and I think like for a bunch of people, we see that graphs are starting to turn into the shiny new toy, and we just and with Microsoft leaning into graphs as well, like I think it's going to stick.
Yeah, I don't know. Maybe Henning, do you have a sense that when you go to a customer, like an account, trying to figure out how to onboard to graph, like what is that first graph? Like, what is there like a pattern in that?
So, in particular with Kusto, because this is a Kusto session, data naturally doesn't land as graphs, so as a list of edges in Kusto natively. Usually data that comes is like log data, right? Yeah. So customers storing log data, for example, Apache logs.
Yeah.
So one IP address was requesting via GET request a specific resource, another IP requested a different resource, and that's as text. So what I see very often in Kusto is what customers really like about it, that they don't have to think about graphs when they stream the data into Kusto. They can do this during query time. So they can say, okay, I might have those logs, but we have a couple of like really, really strong operators to parse the edges from those kinds of logs and then turn it into a graph. Yeah. So that's the pattern that I see for Kusto. In other systems, usually it's the other way around. Like customers have to do a lot of ETL processing to get the nodes and edges like perfectly lined up. And then, their system is shining. I think Kusto is dealing with a lot more like really dirty data. Yeah. Sometimes just text or strings or some kind of dynamics. And then this is definitely a pattern that I'm seeing.
Yeah. Maybe we want to dig more on that on the AI section, where like we're definitely seeing the same thing with Louis, where before in Graphistry we're like, oh, you're in your Jupyter notebook, you do your Databricks query, your Kusto, your Splunk query. Cool, I got my data frame. And we tried to do we make it so it's like a one-liner to make that into a graph and a visualization, whatever. But now with like the AI stuff, it's like it's even easier. Yeah. Like I think also what you're saying is tracks, where as soon as it's logs, you kind of know there's going to be a lot of like event and entity data. And so generally it's like what we see is like, it's either data source driven, where it's like, oh, it's this kind of log. And so this is kind of the natural entities for that log. And here's like maybe a static representation. And then there's also more of like a work oriented where it's like, oh, I'm doing alerts or ticketing or whatever. And so there's events. And so here's the natural event graph because I'm looking at scope progression. Like if I'm doing like an alerting scenario, I'm going to see the alerts and the entities. And I just want to see those linked together and making that easy and smooth. That tracks. I don't know if Sindre, I don't know if you have more questions on this section.
No, but like, we've been talking for like the better part of 6 months now, and I've been starting to love Kusto and Azure Data Explorer coming out of like a Sentinel shop prior. Like, yeah,
it's addictive.
It's addictive. Yeah,
and it's still, and it's kind of a pity. So it's still Microsoft best kept secret. And usually when I'm on, I usually bring those kinds of slides in every session that I'm in. And then I ask the forum, like, what do you think? Like, how many cores are actually running Kusto technology? So I want to ask you two guys. I don't know if I told you that, so you have to guess. How many cores are running Kusto?
Oh, man. Maybe, I don't know, 2,000 node cluster, something like that.
Sindre, go for it.
I'm probably off by like 2 orders of magnitude.
Yeah, it's like now you're going either I need to go bigger or smaller. Like, and I don't think I need to go smaller. I think I need to go bigger. It's like I'll go into the 6-digit numbers, like 100K.
What do you like, cores or machines? It doesn't matter. It's anyway too small. It's roughly it's 9.5 million cores.
Oh my gosh!
As we speak, running, not idling, running this technology. And
what's the biggest tenant? Like, how many cores for the biggest tenant?
How many cores for the biggest tenant? It's probably Microsoft itself.
Yeah. So if you take Microsoft out, is it like 500,000?
I don't know. It's I should do this that kind of math. I don't know exactly.
But it's big then.
Well, okay.
It is growing organically within Microsoft. Like, there was no Satya saying, "Hey, everybody has to use this technology." And right now at Microsoft, there's no number that is not produced by something that's that's not in Kusto. And just yesterday I took the numbers out. Actually today, we're ingesting roughly 480, let's say 500 petabyte each and every day into that platform. It's a couple of exabytes now, so it's just huge. And just think about the potential. Now all of this data is there. You can run graphs directly on those 480 petabytes of data ingested every day. Of course, it doesn't work because it's way too big.
Right.
But you could.
Yeah.
Well, I mean, what's the what's the biggest graph you guys have worked with?
Actually, not that big. It depends. So when I'm in customer conversations, tell me my graph is 14 billion nodes and edges.
Right.
And I said, great. Cool. So you're querying that 14 billion nodes and edges? No. It's like a multi-tenant graph. Okay, so how big is your largest graph? If you're looking at a disjoint graph, maybe a couple of millions, or maybe tens of millions, or maybe at most 100 million.
Right.
That's what we're talking about. Yeah. Like, this is what I discovered in most of these discussions is that, okay, so there is some tenancy in the graph, and there might be hundreds of thousands or maybe even millions of tenants. But each of the individual graphs is actually pretty small. If you're talking about an individual largest graph that we've been dealing with, it's probably in the billions. 5 to 10 billion nodes and edges. It's the largest that we've been working with. But it was an artificial graph. Real world graphs are way smaller.
Totally. I think so we do this open source graph query language. It's also I totally believe that like compute tier, storage tier separation you're talking about. That's like that. All technologies should be compute technologies should be. Well, maybe not all, but like you have special cases. But that's like for the general. And so at the I think beginning of this year, we announced that we did a GPU experiment where on one GPU we were able to do 2 billion edges, and then we're like, hey, cool, let's see what this stirs up. Like what do people want to do? But in reality, it's like everyone just wants to keep doing like these like 100,000 row or 10 million row, and it's like what we found was like maybe I think around the 1 to 10 million edge. Like we don't do just small queries like OLTP, but we'll do like the big analytic, and I think Kusto Graph is doing those. And we find that like having acceleration of some sort. So whether I think Kusto would probably, I'm guessing it's multi-core, I don't know, multi-core and multi-node. For us, obviously, it's GPU accelerated. Like we find somewhere around I think maybe 1 million row count is where we kind of like to flip from the vectorized CPU to the GPU. It's still a single node for us, but it's like, I don't know for you guys, like,
for us, like the technology that we have chosen, especially for Fabric Graph, especially for Kusto Graph, is that we are focused on a scale-up technology first, because I believe in, initially we started with this because we wanted to contextualize time series data, and the graphs that we've been dealing with, let's say in 2021, 2022, they were in around like 1 million or maybe 10 million edges. So we decided, okay, so we want to be fast, and I still think it was a good decision. So we started with something that we call nowadays transient graphs. So graphs that only exist during the lifetime of a single query. After that query, they are entirely gone. So as a user, you don't need to maintain your graph. You don't need to have like CRUD operations running on the graph. You just generate it each and every time. And in the beginning, it took actually quite some time to generate those kinds of graphs. But meanwhile, we found out that actually the time to generate those kind of transient graphs up until, let's say, a couple of millions of nodes and edges takes a fraction of a second, a couple of hundreds of milliseconds. I think in P90, it was something like 100 milliseconds, which is totally fine for an analytical database. So you don't need to care about this. So that was the point when I started to write best practices about how to combine, how to create hybrid approaches of transient in-memory graphs and persistent larger graphs. And that's where I usually want to go with larger customers. I would like to convince them that actually for the majority of their tenants, like small in-memory graphs are totally fine. Just recreate them and don't waste money maintaining them. And for larger ones, it is necessary to maintain them because otherwise queries will take like too much time.
Yeah, we find it's not even like capital cost of like, having more storage or whatever for those. Is like buckets are cheap, but it's just like people hours. Just don't have this extra persistent state and extra system of record you need to synchronize, and it's just just do it on the fly. Totally.
Yeah, and given that, like as you're saying, it doesn't take that long. We're past the point where you click enter and you go grab a coffee and wait for it to be finished when you get back. So who cares?
Yeah, maybe on that note, I'm going to sneak this one in. How about an arrow connector? Like, and speaking of getting data out really fast.
Yeah.
Apparently you're the one to speak to. So.
I know. So we need to improve a couple of things, Leo. Also with our connector that we built, I mean, we might be able to talk in this round about it. I mean, who is listening?
Yeah.
So there are a couple of things that we definitely have to improve, especially also in our connector. But that's not just true for your connector. That's true for everything. So what we would like to be more efficient at is creating subgraphs, creating efficient subgraphs where actually, like the strength when I'm talking about time series with customers. There are some customers when they want to do some time series calculation, they go to the database, pull out 1 trillion rows. I'm exaggerating a little bit. And then they're calculating the time series in the client itself. Not a great idea if you're dealing with a time series database. You want the time series database to do some of those kinds of calculations so that you minimize the data that you have to transfer.
Yeah.
Same thing we want to do with graphs. So we want to get better here in creating efficient subgraphs so that you don't need to pull the entire thing. Only if you wanted to. If you have to do it, okay, that makes sense. But if you want to do like efficient subgraphs and efficient queries, that's something that we definitely want to invest in more, and an arrow connector would be beautiful. I agree with you.
Yeah, like all these property graphs. But yeah, I buy the indexing, and also I'm guessing having cross graph queries. I'm just looking at time here. Maybe we should switch over to the AI side of things.
Yeah.
So I've heard there AI is a thing now. Maybe I don't know. I don't know. Like, have you heard of this thing called an agent? Is that considered entirely?
Never. I was living under the rock. Here in Germany on my farm, there's like no agent. There's cows.
Yeah. So I guess like more seriously, I'm kind of sort of like a a moment in time thing. Like, what's the, I guess maybe as a starting there, like, when you're looking at how people are using like agents or LLMs with Kusto, like you talked about a GraphRag earlier, like we used to see a lot of that. We see a lot of agents now. What sort of, I guess, like maybe two sides of it. What's sort of the normal today? Like as you see people starting to do agents with Kusto, like AI SOC, like that kind of stuff. And then what sort of you feel is more emerging, or maybe it's all the same. Like, I don't know.
Okay, so what kind of became the new normal, at least for me and a lot of other people that are dealing with Kusto, is, and I'm doing this in every demonstration with customers, and some are already getting used to it. It's just using an MCP server that is able to connect that is able to provide tools in order to connect to Kusto. And we invested in something that's called RTI, so real-time intelligence MCP. It can also connect to any Kusto. It doesn't matter if it's an ADX on Azure Data Explorer or an Event House. It's the same API at the end of the day.
Mm-hmm.
And that's something that became, in my opinion, the new normal. So you use a client such as Visual Studio Code or Claude or whatever, and then you ask your question in natural language, and the LLM is using those tools in order to connect to the data. So that's actually quite cool, and I'm seeing that very, very often. Also, like majority of our customers are doing that, and they're doing that probably already. So majority of our advanced customers. I just give you an example from automotive customers. So just to step out a bit of the cybersecurity for a second, automotive customers, they have something like a fleet of cars that are pre-production, and then they have a gazillion engineers who are reasoning over the data, and they try to find specific patterns. And those are sometimes like super specific patterns. And there are some engineers, similar as in cybersecurity, you have some bright minds, I don't know, like John Lambert or a few others, who define the actual queries behind it, but then you want to reuse it for the citizen data scientist. And that's where they use agents quite a lot. So you provide tools, you create tools, domain-specific tools, and they connect to the database, and they hide all of the complexity behind it. So that's kind of, I would say, meanwhile, bread and butter. What I see emerging...
but maybe before we move on, like so what I heard was like, okay, we see a lot of like VS Code users. So I guess it's like a developer doing it because they're trying to write queries. Is that the main way that it gets used, or are there like other ways?
Also dedicated applications. They build dedicated applications, so chat-like applications, which they interact with. Yes.
Okay, so it's like you're seeing a lot of the Copilot is how it gets used today.
Correct.
Yeah. Okay. So so that was interrupting you. So like, okay, so it sounds like we've kind of now the Copilot's connected to your data, or developers doing better queries. So that's sort of kind of like the ChatGPT for business. That's sort of
exactly. Yeah, that's what I'm seeing, and we're building all kinds of, also as Microsoft, like in Fabric, we're building like dedicated environments where you can do those things. Yeah. What I see also more often is like creating multi-agentic systems based on data sitting in Kusto. And what I like in particular is, for example, I did an experiment recently with LangChain and LangGraph, which was very interesting because I found out that LangGraph has this concept of checkpoints, where in each and every super step they store the state of the graph, so of the graph, so that you can do some kind of human in the loop in the middle. And those checkpoints, they're again graphs. So I thought, okay, so there's time series, there's graphs, but there must be something in Kusto. So I created a connector, and then a developer actually created something that's really working.
Just like hit the like the vibes button and then go to production. Okay.
Exactly. Yeah. No, it was actually working. So but it was so that's something that I found super cool, because it's something like a short-term memory for multi-agentic systems that can be interrupted and then can be continued. So that's something that I see, and use cases are, for example, I was working with a company who did like aircraft maintenance, and calculating using an agent the most optimal maintenance layover period. So maintenance layover
scheduling
is all about scheduling. So you need to have a graph of actions, a graph of tasks, and then you have an agent that is creating the most optimal schedule for you. So you have a graph, you have some data in Kusto, you have some time series data, and that's the more advanced stuff that I'm seeing.
Oh, interesting. And then this is where we're moving from Copilot. Like maybe the Copilot could talk to it, but the deeper is like we can now do, like before we would do like constraint optimization for kind of something like scheduling, like linear or fancy or convex, whatever.
Yes.
But yeah, we've been seeing that folks are trying to combine AI with constraint solvers for a while, but now there's like this LLM era where it could just, like we were doing a graph project where it was I won't say exactly who, but like it's like some big manufacturer, and for them is more supply chain. And one of the things we were looking at was like, hey, if you have a surprise war or pandemic or whatever, normal constraint solvers can't really schedule when there's a war. Like what does that mean? Like like the constraint solver doesn't read the newspaper, you know, like it doesn't know how to take that in. But now all of a sudden you can actually think about mixing modalities and having like an agent kind of doing the outer loop to kind of guide some of that stuff. So that's really interesting.
Absolutely.
Oh.
Yeah.
Yeah, and actually that one is also interesting to us because I think what we've been the way we kind of bucket it a little internally is like there's like the Copilot where you can talk to the data, but we also kind of, and I'm curious how you're seeing this, is like we thought a lot of the early stuff was sort of like single turn or just like a few shot where I do like a few turns. But now we're really doing like agentic, like we call it like vibes investigating, kind of like vibes coding, but now for more data and really these like many step stuff. Like where do you feel like when people are doing the Copilot work, do you feel like the current tools, like let's say you're going to do a Lang graph, like are you going to run it for like 5 minutes and it's going to do like the root cause analysis, or it's more like, yeah, where do you feel that stuff is?
I don't know if I have a good intuition on this one. I can't really tell. So what I see definitely what's going on, let's say looking at the Microsoft side and the products that we are building, is we're trying to make this easier for customers to also create things like operational agents. Again, this was an announcement from this Ignite, where actually agents become team members. So you can talk to them, they're connected, they get their context through your business graph. The business graph is driven by an ontology, and the data for this ontology is stored in a graph, in time series, in geospatial, and then those kinds of operators that become something like a real team member. And if they are, I don't know, taking 5 minutes for a job or 10 minutes for a job, I don't really know how that part of the system works. But it's definitely advancing from a Copilot type of work where you just ask your question, or you give a specific provide a specific prompt for a specific ask, to become a real team member.
Yeah. So it's definitely like, one way we can talk about it is like there's like AI workflow versus AI planning, where the AI workflow what we'll say is like, oh, it's sort of like before you have your like static like DAG, like Lang graph, you have your DAGs as well. But you have like your static sequence or your rule set, whether it's linear or like an interesting shape, but it's sort of like it's predetermined. So it doesn't matter if it's like Python rules, AI or not AI, that's like a static workflow. But then the AI planning is when we have the AI sort of making the decisions of what to do when. That's really, I think, when we talk about agents, and agents in practice means plans and self-planning. And so it sounds like in practice, people are doing Copilot. Maybe they're doing longer turns, which is getting more towards that agentic self-planning. But and then directionally, you want to have that, and that's where we want to go. But maybe in practice, we're not quite there yet. At least, like that's definitely that everyone's kind of trying to figure out right now.
Correct.
Awesome. Okay. And then actually, I wanted to go back before we lost it. Like, so you mentioned GraphRag, and then you mentioned using Kusto as like an in-memory layer for your agents for kind of like your transient example, like a little short-term memory. Are people also doing long-term memory in Kusto, or you still?
So long-term memory is, at least the way that I understood it, most of the customers who are doing that, they're storing actually real embeddings, so vectors in Kusto. That's also something that, in this era where Pinecone was super hyped and all of these vector databases, I looked at Kusto, we have a specific data type called dynamic, which you can use to store like JSON data, or also arrays. And
Yeah.
so we can store arrays of floats. So we are a vector database, like probably like
That's
others
familiar.
as well. And then there were some more serious projects where there were hundreds of millions of documents which had a vector embedding for them. So we optimized quite a bit here. So we now have like optimized dynamics. So you need to configure it a bit different. Usually you don't have to configure it, but this time you have to say explicitly that it's a specific type, so that the floats are more efficient in those areas and that they don't like grow too large. And we're also working on specific indexes for vectors. I'm not sure when this is going to come, but I know that we are working on that. But even without the indexes, if you do some proper partitioning on the data, we achieved really great results even without a specific index.
Yeah, we were doing a training on kind of like AI for security workflows, and we kind of like, half of it was how to get going with agents, and half of it was get going with RAG. And like for us, it's kind of interesting in twofold. And maybe it'd be a little spicy here. Is one of the participants asked, like, do you even need RAG, or is like the use case for RAG like it's still there, but somehow feeling like it's shrinking? Where like, I mean, sorry, vector RAG, like maybe you just go directly to the database. And then the other part is like when we're doing the different sessions on how to actually get good quality on RAG, what we found was, and if you look at Anthropic and OpenAI, they'll say the same thing. The vector database companies maybe don't like the answer as much, but one is you actually don't need, you can just do direct retrieval most of the time. But then when you do get into the vector stuff, before you want to go fancy with GraphRag, like maybe you want to do these fancier vector indexes, but actually much more lift is actually start with direct retrieval and then layer on like, text retrieval and layer on direct vector retrieval. And only once you've done the multiple modalities and you've actually done re-ranking across those, and so that you kind of getting the different interesting bits, only then like maybe about that point you understand your workload more, and maybe you go deeper into direct retrieval or you go deeper into vector. But start with just like simple on each and just getting the multiple modality. I don't know if that's like what you're seeing for your workloads, or GraphRag is the thing to do, or I don't know.
No, I don't like GraphRag in terms of implementation. I haven't really seen a lot of implementations for that on Kusto. I bring it in my demos, and it's actually quite clear, and it resonates with people. But having seen it in real life, I'm not. I haven't seen that. I haven't seen that. There might be a couple of exotic ones who are actually doing that. I know that from there was a project, like a military project, which I wasn't involved in. It's a tented one, and they worked on it and were actually pretty successful with it. But like in the wild, I haven't seen that actually.
Yeah, that tracks. Maybe before we wrap up here, like I don't know if there's like any kind of thing you want to share with the community. Like, you've got your moment, you've got your stage.
Oh wow!
Yeah, I'm putting you on the spot.
You shouldn't do that. No, actually. So
like,
okay,
what is it? If someone wants to like hear more from you or anything like that.
No. So there's a couple of really interesting investments going on right now in Kusto. So as I said, initially we started when it came to graph with in-memory graphs, the transient graphs. Then we transitioned to persistent graphs and graph models. So now graphs are actually persistent first-party objects in Kusto, like the first ones after all of this tabular stuff. And now we take the next iteration. The next iteration in Kusto is going to be a dedicated persistent format for graphs. So far we were cheating a little bit, but we're also not yet GA with the persistent graphs.
So it's in preview.
What we created a dedicated format for it, which will eventually also is going to spread over all Kusto. So if you want to check it out, it's called Amudai. It's a new format for the Kusto extents, and the graphs are the first ones who are going to get it. So this is a major investment for us for entire Kusto. And then if you want to hear more about it, there are a couple of like specific Kusto communities. You can check out, for example, KQL Cafe. Last like 2 months ago or a month ago, there was a KustoCon. There are also a couple of videos where I'm presenting, and then let's say, I would just like to say thank you. Thank you for inviting me to this session. It's an honor actually to be the first one.
Yeah.
Here, I did like
the bar has been set.
no, it's fine. So I want to say thank you, and the great collaboration that we are having, and I believe we can, like with your product, being able to show and analyze those graphs visually using GPUs. I'm always like raving about it, and it resonates really, really well with customers. I believe you're really contributing to a lot of cybersecurity teams, not only at Microsoft but also on the planet. So thank you for your work. I think you're going in the right direction, especially and also with Louis. I want to see more of that, more of those great videos. Also with you, Sindre. So thank you.
Yeah,
Thanks
you need to find some CTF hosted by Microsoft that I can lose.
Okay.
Oh man, maybe another day we talk about the KDA. That was a twister. That
was a.
Yeah. Thank you Henning for taking the time for this. I know like the hours are a little wild with like the whole Europe US thing. So we'll at the I think we'll have someone like wrap up the video and like put in links to all the resources you're sharing here just to make it easy for folks, and then hopefully we get that video of Sindre versus the intern. But I guess a little reminder for folks to stay on. So we're basically, this is a chance. Like honestly, I learned a bunch on this one. I hope you did too. We're going to be having Roberto Rodriguez from running NVIDIA's AI SOC and from the Microsoft's AI Red Team efforts. So I always learn a lot when I chat with him, and it's always like fascinating. So I think we'll be having a bunch of good folks this season. So go to louis.ai, just sign up on that form there. You'll hit the marketing whatever button, or if you're like a YouTube or LinkedIn person, I don't know that as much as well, but I think there's some sort of like follow button of some sort. And then again, I think so whether Henning catch up with us in Germany at the end of the year. Apparently that's the place to be if you're doing a lot of this investigation work. But yeah, all those other avenues as well. We'll just check the links at the bottom. And with that,
and I think also like for people watching it either live or down the road, like if you know someone that's not like there might be people doing cool stuff with graphs and agentic AI that we don't know about because they might be big in your country or something like that. Hit us up and like recommend them, like you should talk to this guy. That would be awesome, because grow the community, get more people into graphs. That's always good.
Yeah, if there are any like tools or whatnot, like we're definitely, we naturally like veer towards I think like graph and agents and some of the deeper tools. But anything you find interesting, let us know, and we'll see if we can fit it in. All right. Well, yeah. Thank you, everyone, and I'll catch everyone on the next one.
Yeah.